Hello, I'm on site here at Embedded World 2026 on the DigiKey booth, and joining me now is Mike Engelhardt, who is the founder of Qspice. And today we're going to be talking a little bit about Qspice and its most recent updates from the last 12 months. So Mike, thanks very much for joining me. Why don't you introduce yourself briefly for us?
Well, yes, you are correct, Paige. I am Mike Engelhardt, and I'm probably best known for having written Qspice. I'm the author of Qspice, which I wrote a long time ago. And lately, I only focus on Qspice. And in general, over my life, I've written simulators and done a lot of analog design.
Okay, so perhaps for those unfamiliar with Qspice, can you sort of in simple terms describe it for us? How does it benefit engineers?
Qspice is basically Qspice done right.
Okay.
I wrote Qspice close to 30 years ago now, and I wrote it very fast. I went from nothing to initial release in 10 months.
Okay.
Where Qspice has been many years of more intense work, making something that's actually implemented correctly now. And it has really outstanding performance. Outstanding Spice basics. It has outstanding mixed mode simulation capability. It has fast graphics with the GPU. And what it does is it helps engineers design circuits.
And how would you say it differentiates itself from other Spice-based tools in the market?
Well, the first thing to understand about simulators is that there is a profound similarity between simulators and compilers.
Okay.
That similarity is you only need one.
Okay.
Okay. If you're using a compiler, don't waste your time with the second best compiler. You only need the best compiler.
Yeah.
And so if you're going to write a simulator, you have to be convinced, you have to know that you can write the very best one, better than one exists. So that's what Qspice is. It is the best Spice program, and it uses numerical methods that weren't known as little as 10 years ago.
Fantastic. And I understand that back in March, you announced a major addition to Qspice, the ability to generate JFET, MOSFET, and diode models directly from standard datasheet parameters. So how does this change the way that engineers approach design modeling and early stage design?
Well, anyone who's tried to simulate analog circuits has come into the problem that the model isn't available for what they want to simulate. With these new model generation tools, these empower standard rake and file engineers to generate their own models from the data sheet. They did, basically this is a separate tool you launch in the corner of your screen, and you make the PDF of your data sheet large on the screen, and you digitize the output characteristics and body diode and gate charge characteristics, and it will make you a model that precisely follows that data.
And I know that you've called this datasheet to model tool the most important simulation improvement since Qspice launched. So from a practical engineering standpoint, what kinds of designs or workflows will see the biggest boost in productivity and accuracy from being able to generate these models, in minutes instead of hours?
Well, most semiconductor manufacturers are not that good at making models for their products. And it's really just that making the semiconductor and modeling them are just completely independent skill sets. So there's no reason why they should be able to. The model generation tools basically are an expert system that can make that model for you. So you can make a model for anything you have a data for.
Okay. And back in October, I know you also launched a seasonal update to Qspice, which I love, by the way, Pumpkin Qspice. Fantastic name. So what were the core engineering motivations behind that release?
Okay, yeah, it was a great name. The marketing group at Qorvo is a force to be reckoned with. Just like stand back if they're going to do something. So there was a lot of things in that release. There was the ability to there was a Berkeley socket, so that parts of the simulation could be done on different machines. It included Python. You could implement your device equations in Python. It'll make boilerplate code for you. You just type in the part. You can just implement the thing, and all the framework is made for you.
Yeah.
There's a lot of incremental improvements that were maybe more functional than these fancy, unique features. The rail-to-rail op-amp was improved. There were some numerical methods improved. The IDE for generating source code was improved. There were a lot of important little improvements, but the big things was that it handled Berkeley sockets in Python and Rust and Java.
For those that are using Qspice for the first time, what's the aha moment that you hope they experience?
OMG, this thing is fast. That's the effect I want.
Yeah.
I want people to realize that they've never seen anything run this fast before, and this accurate, and robustly, and this capable.
Yeah. And then zooming out then, what's your long-term vision for Qspice?
Well, I have to quantify this. I undergo ambitious projects with a lot of technical risk. Mm-hmm. And sometimes I fail.
Okay.
And you never hear about them because I don't announce things ahead of time. So there's not a full answer on a roadmap I can give you. There's a lot of things I've added recently. One thing I'm working on now is the new device equations for lateral power MOSFETs.
Okay.
The model generator was for the vertical devices, as is common for silicon devices, but I'm trying to make a native device for lateral, like GaN and all that, and those will be very significant new features.
Fantastic. Well, I'll stay tuned to see what happens, and I hope for some more seasonal updates and some more fun marketing.
Yeah, Easter's
names.
coming up. Maybe we'll have Bunny Qspice. I don't know.
Let's see what the Qorvo team can do, eh?
Yeah.
Thank you very much, Mike. It's always good catching up with you. I appreciate your time.
It's been totally really real.
Fantastic. Thank you.
All right.